Thanks everyone for allowing me to speak here at PyData Global. I'm Geir and Hjelle, and as the title says, this will be about maps. Let me just very quickly rush through my background. It's already been mentioned. I live in Norway, and I work for Real Python, which is a website for essentially Python education. So you can come there and read articles all about Python. I've been working with Python now for about a decade. And earlier, I guess my main background comes from working with the Norwegian Mapping Authority in terms of maps. And I've also been doing some consulting work with maps. So let's dive into it. So essentially what I'm planning to do here is do some demos of a few different packages. And kind of just give you a teaser of what you can do with these kind of things. So the first one that we'll have a look at is one called Folium. And Folium, let's just run this code so we can have a look at it. It wraps around a JavaScript library called Leaflet, which kind of runs a lot of open source versions of maps. So essentially here you have an interactive map. We can move around on the map, we can zoom in on the map, we can zoom out from the map, and things like this. So it's kind of what you're used to in terms of a web map. And getting this to run through Python is essentially as easy as just creating this map object right there. Here I just say, where do I want to start kind of centering my map? So I could say that I want to start closer to Oslo. And here I kind of say at which zoom level I want to start. So if I kind of come out like this is zoom level close to 0 at least. And as you kind of go in, it's more and more zoomed in. So for instance, if I do something like this, then I'm here now in southern Norway, for instance. So you can kind of set up things like this. So this gives you immediate access to a map. And let me actually one little thing before I move on. So this I'm running just in a Jupyter notebook. So here you can kind of see the map directly, but you can also just save this by doing something like this. You can save this as an HTML file that you can then serve however you serve static HTML files. Okay. So what else can we do with Folium? So we can add in more information on top of the map. So it's just not showing a map. So for now, I'm just going to define 4 locations that I'll kind of be using a little bit throughout the presentation. So essentially here I have a name, Andenes, right there. And then I have the latitude and longitude. And similar here for Oslo, Barcelona, and St. Louis. So let's just define those. And then let's see what we can start doing here. So here I'm just creating a new map, centering at some location like this, adding a zoom. And here I'm also just choosing a different tile set. So the tile set defines the look and feel of your map. So if you just run it like this, you can see that this Stamen watercolor tile set, which is made by Stamen, it's a really fun tile set that just looks like it's a watercolor painting, but it has all the details. You can see here, if I actually zoom into towards Oslo, you can see that we get more and more detail. And for instance, up here, we're up in the mountains, there's a ski arena. So this weird little shape there is a ski jump, for instance. So it has a lot of detail, and this is based on top of OpenStreetMaps, which is sort of like a Wikipedia for maps. Okay, what could we do now with these locations? So here I just add a loop where I just loop over my locations dictionary, and then for each of them I add a Folium marker. So you can see here I have a marker. I give it the latitude and longitude. I specify a name as a pop-up, and then I just add it to the map. So if we run this, we get the same map, but now you can see that we have these small markers. So there's St. Louis, Barcelona, Oslo, and Andenes. And again, we can kind of still zoom in on this and kind of see more and more information. In addition to these kind of markers, you can also have circles or nice logos on things. You could add lines, lots of information you can kind of add on top of this if you want. So in general, Folium, it's a great package just for exploring and getting an overview of the data. And also you can use it to visualize your data to end users, since it's a very intuitive way of presenting your data. That there is a great tutorial, sort of like a quick start, that kind of shows more of this at their webpage. One thing I didn't show here, that it also supports these choroplot plots, where you can kind of add a lot of color to areas and so on. We'll see some example of this later. So let me move on to GeoPandas. So GeoPandas is this kind of magical package that just brings together a lot of functionality from many different geospatial Python packages. And it's really powerful for doing any kind of geospatial analysis. So some of the packages it builds on top of are Pandas, which you may be aware of. It's kind of one of the big data analysis packages. Shapely we'll have a look at in a minute. It's just a sort of like a package for describing points, polygons, lines, and those kind of things in a more abstract setting. Fiona is a library that can just read and write tons of different geofile formats, since geospatial information often comes in weird formats. So some of them are things like shapefiles, GeoJSON, other stuff. Then there's a package called PyProj, which is based on the Proj project, and this is for projecting coordinates essentially, or transforming coordinates. And we'll not go deep into this at all, but I'll kind of just point out, so far we worked with latitude and longitude, but often if you need to do precise geospatial analysis, you want to transform to other coordinates, which may work better, especially locally. So this is something that is done by PyProj. We'll not go deep into detail of this package, but we'll see an example where it's used. Then there's also a package called Descartes, which is kind of something that interacts with Matplotlib for creating these kind of more publication type plots and figures and maps in this case. So it's nice for drawing stuff onto this. And GeoPandas has recently also gained support for interacting with Folium. So we'll see an example of that quite shortly. So before demoing GeoPandas itself, I'm just going to show you a little bit about what Shapely does. So here we have importing Shapely, or I'm imported the geometry part of Shapely. And here you can see I define a point, and here the numbers are coordinates, but they don't have any, say, geographical meaning in this case. So the Shapely doesn't care whether this represents latitude, longitude, or some other coordinate system. So if we just run this, I have here defined point, a line, and a square. This square I define as a polygon. Then we can have a look at them. So for instance, I could just look at the coordinates that we just defined. So here we see that the point coordinates are 2 and 3. I could also go in here and look at, for instance, the line coordinates and see that I get this 5, 0, 2, 6, and so on. If I just inspect the line or the square here in the notebook, it also has support for just drawing itself. So you can kind of get an overview of how things look. As you can see, this is kind of abstracted away that you don't really see. If I change the line coordinates, the line would still more or less look like this. What's maybe even more interesting is that Shapely comes with support for lots of different calculations, transformations, predicate checks, and things like this. So for instance, I could put a point together with the line. So now there you see my point, and there I see my line, and now things are kind of looking a little bit, I guess, they're still abstracted out, but they're still a little bit more concrete. Or I could just look at the actual string representation of this, where you can see that this is now a collection of a line string, which is Shapely's name for lines, and a point. And I can calculate stuff. So for instance, in terms of these coordinates, I can find that the distance from the point to the closest point on the line is 1.34. Or we could take our square, calculate the area, or we could do checks between different things. So does the square contain the point? Is the point inside of the square? Yes, it is. Does the line intersect the square? So does that cross the square? Yes, it does, and so on. So it kind of comes with lots of different checks like this. Okay, back to GeoPandas. So what GeoPandas supports or gives you is a geodata frame. So this is more or less a pandas data frame. So it kind of has the same setup. So you have your data ordered into columns and rows, where typically you'll have one variable in, say, the statistical kind of sense, or a feature as one column, and then you'll have an observation as a row in your data frame. So what I'm doing here is that I'm just creating a small geodata frame from scratch. And this looks a lot like how you'd create a pandas data frame, especially if we disregard these two lines. Then what I'm doing here is that I'm just creating a column name and a column size. So let's run this and have a look at it. So the name I'm just taking from these locations that we defined earlier. The size is definitely just a very artificial feature, but I just take the length of the name and store it here in a separate column just to have something to play with this very simple data. Now, the magic, in a sense, of the data frame comes from this geometry column. So you can see here that it looks more or less like a regular column. But the naming of this is kind of special, and it plays a special role with the geodata frame. And what I've put into this column is now these are shapely points, and I just took the latitude and longitude and threw it into here. And one tiny note is that I kind of reversed the order, so GeoPandas wants longitude, latitude. I also defined here something called a CRS, a coordinate reference system. And this is where I kind of take my abstract numbers and give them meaning. So this is sort of like a big database of different reference systems. And 4326, that is your typical latitude, longitude reference system. So this is now a data frame, but it has some geometrical superpowers, as we'll see quite shortly. So the first thing is that we can look at these things in Folium. So the method explore like this lets us explore our data. So you can see now that it just pops up a Folium thing. And if you stare really hard at this, you might see that there's a small blue dot at Oslo over there. There's another one down here in Barcelona. So the default of points is not that readable, but we can add in lots of different parameters to kind of change how the map looks. So in this case, I'll just add a slightly bigger point. So we could probably even make them bigger than this. And now we can kind of see that at least here I have my points. And if I would have a data frame with even more fancy geometry, then that would also be plotted on top of here. So we could have lines, polygons, and all those kind of things. Okay. Geodata frames are pandas data frames. So if you've been using pandas a little bit, you know that you can do lots of interesting analysis on this. So here's a very basic filter. So I'm just doing a query on this. So give me all the observations or rows here where the size is less than 8. So that, remember, the size in this case was just the number of letters in the name. So that gives me these 2 points, for instance. Instead of creating your GeoPandas data frames from scratch, you typically want to read in data files. So here I have already downloaded some open data that are essentially just information about all the countries. So it looks more or less like this. You can see, let's see, there we have some names here. If I scroll all the way to the right, we'll see that we have this geometry column. That is the all-important one for our geodata frames. And there's even much more information here. So if I look at all the columns, I don't remember, I guess we saw it recently that there's 50 columns or something like this. Let's here just point out that there is a population estimate column. Let's see if I'm not able to edit there. And also there's a continent, which we'll use later, and so on. So that there's lots of information we can pick out of this. But first, let's just do, so earlier we did the explore. I can also do just a dot plot. And this just plots our data now as a matplotlib kind of plot. So if you look at this a little bit carefully, you should be able to see that there are some borders between each of the countries here, but we'll see that much clearer soon. Because here I'll just do another filtering, and here I filter out, let's just look at the countries that have more than 50 million population. And here you can see that we still recognize some of the countries. There's Brazil, for instance, South Africa, and so on. And what I've done here then is, I guess we can just quickly look at this. I get this filtered data frame, and then I just say that I want to plot that filtered data frame. Now, to make this even more interesting, we could also add some color. So this is kind of what I mentioned earlier as a choropleth plot. So in this case, I'm almost plotting the population, essentially. I'm using a color map here, and then I'm plotting what I call here the log population, mainly just so that we don't get just kind of distracted by some of the countries having extremely high populations and some small. So now we kind of are able to see a little bit of the difference between the smaller populations as well. So to kind of sum this up, we can think of GeoPandas as kind of the workhorse that can do all kinds of analysis of geodata. It kind of brings together all of these different packages, and is extremely powerful then to do all kinds of data analysis, conversion, transformations, and visualizations. A small little package that I also kind of want to highlight a little bit, this one called Contextually. And this kind of combines a little bit the power of what we saw in Folium and the images that we saw, sort of like more of the Matplotlib kind of plots. Because what we have with the Matplotlib kind of plots is that we get these kind of plots. So here you can see I take this country list and I just look at everything that's in North America. And again, I use the population to kind of give me some kind of choropleth thing. Now, by themselves, these may or may not be interesting. In this case, the country shapes is something that we often are able to recognize anyway, but we can add some context to our maps by using by using Contextually. And what it does is that it just runs off and downloads these kind of web map tiles, so the ones that you saw in when we were using Folium, and adds those as background. So now we can see that, okay, we have the North America here, we see a little bit of Africa over there, we see a little bit of South America over there, and so on. So this can be extremely useful, especially if you're doing more kind of detailed things. So how this Contextually work is that you just create your regular plots, and then you just say, I want to add a base map to this axis. So that's kind of the plot. And then here you can choose what kind of zoom level you want on your background map. I'll just note that since this kind of runs off and downloads these web map tiles, if you do a high zoom level here, things could take a long time. Here's a different kind of plot. So here I'm plotting, let's see, these are countries in South America where it starts with B. So this would be Brazil and Bolivia. And again, I color them by population. And now if we add in the base map for this, now you see it takes a little bit of time, but there we go. And what I've done here is that instead of using just the default map, I'm using some tiles from Esri that gives us the satellite image instead. So you can choose different kind of providers for your backgrounds. We can also work with GeoJSON. So in this particular file right here, I just have actually one polygon, something called Holmenkollen, which is this arena up in the hills above Oslo that we zoomed into earlier in the talk. And here I also use something called Norge Bilder, which is a service in Norway for just getting access to really high detailed images. So these are aerial images. And here you can see I can combine these. So essentially the same principle that we saw in the South America earlier, but now we're kind of doing it much more locally. So there you can see the ski jump right there. Here's the arena with the stands and so on. So with Contextually, you can kind of extend the areas where you can use the web map tile services and things like this. It also supports some simple transformations, and it's great for building these kind of publication visualization maps. And yeah, the last package I want to look at is works a little bit differently from what I guess the ones we've seen earlier. So GeoPandas works with what's called vector data. So you have everything is defined in terms of vectors or coordinates, and you kind of have a lot of freedom in terms of directions and things like this, lots of flexibility. But often you also have data that are just data on a grid, so typically are images and things like this. And the example data I'm using here is a surface model that kind of then just gives me access to the exact height of the surface. And this particular one is, again, in the area around this arena that we saw in the previous plot. If I just use raster IO here, I can open this file. You see it's a TIFF, or I guess a GeoTIFF, that comes with a little bit of extra information. And in this case, we can again see the CRS, the coordinate reference system, and it has some kind of number over there. This is the UTM-32 coordinate system, if you know about those things. And it comes here with this transform that kind of says how the grid points kind of translate to this coordinate reference system. So what is this file really? Let's try to plot it. So I can plot it like this. And what you see here on the left is now the colored version of the data inside of the file. So this, think of this more or less as a, say, a NumPy matrix that where you have your array, you have your rows and columns, and for each point you have the height above sea level. So in this case, it kind of comes from the blue here is close to sea level, green is kind of going uphill, and then the brown stuff here is kind of on the top. And if you notice the little green dimp that we have over there, that is the ski jump arena. So with raster IO, you can do the different kind of analysis on it. So for instance, I can ask for getting the contours, which are just lines of the same height, essentially. So this will look like your height lines on a regular map. And maybe the ones that you'll really, again, point out there are the ski jump arena. You can kind of see here in the top there. We could also now combine this with what we saw earlier. This let's see, there we have Holman column, which was this GeoJSON file. And I'm here saying that I want to just mask out my surface model with this GeoJSON and crop it off. And then I'm going to show what I'm left with here. So if I do this, you can see now that I'm kind of just getting a smaller part of the height model that I saw earlier, but the limits, the boundaries of what you see here in the mask, at least the lower boundaries, are coming from the GeoJSON. And then it's kind of cut off on the top here because I didn't provide a surface model that actually covered the whole arena. But again, you can kind of see the ski jump and the runway down there. So to sum up with raster IO, what you get here is then a lot of power when you work with the raster data. So raster data are kind of opposed to vector data, and raster data are the ones that are kind of gridded data. But as we also saw, we can kind of combine our vector data, like the GeoJSON thing we had, to mask our raster data and things like this. So with raster IO, you can again do lots of different transformations. You can change coordinate reference systems if you want to. You can combine different raster data into one bigger one. So I didn't show it here, but if I had downloaded kind of the surface model right next to the one that we were looking at, I could have kind of covered the whole arena. So that takes me to the end of the presentation. So thanks everyone for your attention. I will put the talk on GitHub, and if you want to reach out, I'm available as Hjelle in most places.
Thanks, Geir. We have, really, it was a great talk. I got a really, as far as the basics are concerned, it's really a great talk. So
Thank you.
we have some questions out there. I'd like to pitch them to you.
Yep.
So Carlos has question that can I change the base map when geopandas.explore when using geopandas.explore?
So yeah, the quick answer is yes. And let's see if we come back to GeoPandas here. So I just showed, let's see, GeoPandas Explorer here. So I think I should be able to do this. Yeah. So GeoPandas Explorer comes with lots of different parameters. So you can kind of change out more or less everything it does here. And it kind of passing those kind of parameters down to the underlying package. So this marker keywords that I added here passes things down to volume for the markers. But yeah, I think here, yeah, we can see here we can change tiles here, for instance, to change to a different tile set. So I could do here stuff like, let's see, stammen, watercolor. And we get a different base map for it.
That's really great. We can have another question, and that's by Jota Mails. I've had trouble with GeoPandas. Spatial was slow. What kind of techniques, tips, parameters should I look into when that happens?
Yes. So let's see if I. So I guess I didn't really demo this properly, but in GeoPandas, you can do all of these underlying shapely operations. So I could ask, for instance, which country is inside of a bounding box or things like this. It can definitely be slow, and there's an ongoing effort to make it faster. So if you have the luxury of it, one way to make it faster is just sit and wait for a few months. But otherwise, what's really important is kind of the detail of your geometries. So if you're kind of doing things like intersections or things like this, and you have very complicated geometries. So if you have a very detailed geometry that kind of goes, let's see, I don't remember if we had a good example down here. So this one is not very detailed. For instance, in Norway, you can see we don't have any of the islands, but if you kind of have one very detailed one with all of those things, and they're not really important to your analysis, it can help a lot with speed by just simplifying your polygons. And some of the ways of doing that is maybe you can get away with just using something called a convex hull, which is kind of just a polygon that's drawn around your actual polygon. Because the simpler polygons you have, the faster these kind of operations will be.
Yeah, I quite sort of agree with you. Yeah, convex hull is quite a good option to, you know, speed up over here. Plus, I'd like to chip in one another package called as GeoFeather. So GeoFeather also is quite good at handling shape files if you are talking or just reading the geometries and writing these geometries. So in case of complex geometries, GeoFeather has a sort of around 1.5 to 2 times the speed up as compared to GeoPandas. So
Okay,
yeah,
nice. Thanks.
yeah, and we have another question that is by Rishika. Do you have any advice for how to deal with clustering points on the map when we zoom out? Real time clustering is very slow for us. We don't use Python though. Yep.
Right. So let's see if I just so the yeah, so the question kind of deals with when you have lots of points, so I don't really have a good demo of it here. When they kind of start to overlap, you can kind of cluster them together as one, and things like this. I have not really dealt with that personally, so I don't know if I have any good advice. I've been kind of using whatever's in some of the packages where I. So yeah, I don't really know good ways of speeding it up, I guess, unfortunately.